Good evening, everyone, and it's great to see so many keen faces and people on the camera. So that's excellent. Changing times, changing seasons as well. We've still got a tiny bit of light in the sky tonight here in Scotland. So yeah, the energy is changing for the year. This topic on iron in a sporting context, if you look at standard sports nutrition advice, for about 20 odd years, iron has been recognized as a needed mineral in a sporting sense because athletes might need it more than non-athletes. So it's a big topic. Gradually in sports nutrition, other things have come in, like vitamin D, they're now interested in, antioxidants are interested in, but within a functional way of thinking about how the body works, we can take this discussion to a different level. Rather than just, okay, food and supplements, we can try and dig in a bit more, look at genetic susceptibility and different lifestyle parameters that could increase the need for iron levels, iron uptake in the body. So I'm really glad to welcome back Karen Harrison. She, in my mind, is a genetic expert and really knows her stuff. And she's a really good example of an integrative thinker. So thank you, Karen. We'll have the same sort of format as normal, and that is sort of 45-minute presentation. As Karen gets started, I'd like to ask you 3 questions. Where you are in the world, what you do, and what you'd like to learn tonight. So we'll then, when Karen's finished, we'll then go to a Q&A. So when she's talking, just feel free to type in the chat box and we'll have a good interaction in the chat box. Okay, over to you, Karen.
Super duper. Thank you very much, Ian. I apologise about the first slide. I understand it's a bit blurry, but the rest of the slides are perfectly fine. But thanks, Ian, for inviting me back for the 3rd year. I really love and enjoy supporting anybody who's interested in sports and basically how the body works, particularly in order to better themselves. So this evening we're going to go through into iron metabolism, the genetics behind them, and there is a novel approach right at the very end, a bit like one of those storytellers. There's a little catch at the end there for you. So we'll no further ado, we'll carry on and see how far we get. So this is what we're going to do today. We're going to go through all of the different areas in regards to, this is my introduction. Like I say, you've got that ready for your notes. Now, just to let you know, if you've not been on one of Ian's webinars before, he very generously also sends out the recording and the slides to you afterwards. So if you are a slide person, you will get a copy of these, no problem at all. All right. So let's see what we got. Oh, wrong way. Here we go. Right. So we're going to have a look at genetics, as I've said, but first of all, it's really an introduction to genetics. Some people in the audience won't know anything about it. Some people will be absolutely probably better at it than I am. But basically, it's the relationship between the food that we eat and our genes. And sometimes our genes can also interfere with the food that we eat. So we tend to say it's nutrigenetics. It can also be called nutrigenomics. But it's this seesaw event of what's actually going on, and it's been going on from the second you were created. All right, so our gene is basically, or we're made up of our DNA, and it's effectively got 4 different bases on there. And those 4 bases are on the screen, as you can see them, and that is then translated into RNA. Now, the difference between DNA and RNA is that one of the bases has actually changed. And in RNA, we have uracil, and you'll see that on the slide there for you. In the very first webinar I did for Ian, I actually went through this in a much more detail. So if you want more in-depth information about what genetics are and that sort of thing, if I can signpost you to that, because today we've got lots to get through. However, we've got 4 different bases. There is a difference in DNA and there is a difference in RNA. And the difference in RNA is that we now have uracil. Okay, so effectively, what is a single nucleotide polymorphism? What is that? So in your code of your genes, you've got these 4 bases, so in other words, 4 letters, and throughout your genes, it's just literally made up of string or great big long sentence of all of these 4 different letters, these bases. Now, occasionally, very kindly or not so kindly, is your parents will actually give you a genetic code that's got a few spelling mistakes in there. And those spelling mistakes can have an effect on the protein or whatever it is that you're actually making. So it might be a liver cell, it might be a skin cell, it might be whatever it is that that particular gene has actually been programmed to actually make. So there's this little example on the screen here. The 3 bases AUA will make isoleucine. If the last base was actually changed to G, so it's AUG, it'll actually make a different amino acid. So in this case, methionine. So what that might mean for you is that actually a particular action might be slower for you than it is to somebody else. It might not make any difference whatsoever, or it might make a profound difference. And it's these that I'm actually looking at. A lot of genetic companies have different ways of actually really giving the results. I use a traffic light system. So green means you are the same as the rest of the population. Yellow means one of your parents has given you a particular code that has been changed. And the red, it means both of your parents have. But on all of my reports, it will actually tell you exactly what you need to do. So even if you're not really interested in this or don't really understand it so far, that's absolutely fine, because most reports these days actually tell you, you've got this, you need to do that. All right. So today, minerals. Now, minerals themselves, we've got loads of them, but of course today we're really only talking about iron. The chemical symbol, as you can see, is Fe, and it basically is one of the most common elements on Earth. And it's also known as ferrum, or ferrum is the Latin for iron. So iron is a mineral that the body uses for multiple reactions, okay? I've seen written in research, it's believed that more than 180 different biochemical reactions that iron is actually involved in. Now, the main ones that they're actually familiar with, or you should be familiar with, is hemoglobin, which is a type of protein in the red blood cells carrying oxygen from your lungs to many parts of the body. It's also involved in the production of ATP, and ATP is a molecule that carries energy within the cells. It's known as it's reducing oxidants. So in other words, you will be producing inflammation. Everybody does, just depends on how much, depending on what exercises you're actually doing. And inflammation increases the risk of free radical production. Free radical is a substance that needs to be reduced. So in other words, it needs to be almost kept in check. It's that unruly teenager. So otherwise it will actually go on and create more issues within the body. And in that ability to actually reduce that, iron is one of the cofactors in order to do that. So it's really important. And the last thing here is also detoxification. Now, depending on which expert you actually look at or listen to, there can be anything from 3 to 5 different phases of detoxification. The actual nitty-gritty of that is not what we need to know about today. However, there is in the very first phase of detoxification, it's very well established that where the hepatocytes in the liver basically were in there, all of the metabolites you're trying to detox become much more reactive. And in that process, you have enzymes, they're known as P450 enzymes. There's multiple, great big families of them. And basically, in order to carry out their ability to metabolize and do the phase 1 detoxification, you need iron. They are iron dependent. All right, so it's really important. There's only 4 things there. There are hundreds of different biochemical pathways that iron is actually used for. So for athletes, iron is really important. It's important for energy production. It's important for oxygen carrying. It's important for inflammation control and obviously detoxification. Now we're going to start to talk about iron deficiency, and iron deficiency is pretty much known as really just before we get to anemia states. So a lot of people will know about anemia, which obviously is low levels of iron, but an awful lot of information isn't actually it isn't really researched into the actual levels or low levels of iron or iron deficiency. Now, people that do know me, I rarely say the word deficiency. I tend to say if you're low in micronutrients, you have an insufficient amount, because if you had a deficiency, you wouldn't be alive. With iron, you can still be alive and be in a deficient state. So hence why I'm actually using that today. So now, also, humans are unable to actually make iron. We have to eat our iron, which for some people is actually a big struggle. Okay, so as this slide really indicates, the differences in iron and ferritin. So this is why that you really need to, when you go and have blood results done, you really must go and find or ask for a full blood count with ferritin, because the ferritin is actually the stored iron and the serum iron is actually what's present in the blood cells, and that will come evident as to why you need to know the ferritin levels a little bit further on. All right, now all blood panels from majority of labs that you'll be using, or whether it's from the GP, they will measure these, and you can see on the screen there that the different levels that somebody could be between in order for them to either be normal or optimal, or what I call the red flag levels. So in other words, if somebody has a serum iron level of less than 4.5, or they have ferritin levels of less than 8, then that is to me a red flag. That means we need to do something about this, because if that person doesn't have symptoms, they should have, for instance. All right. Now, on that particular slide there, all those reference ranges are measured in international units. So be careful, because it depends on where you are in the world. The levels might be slightly different. All right. Now, when I deal with athletes, which I do quite often now, basically I'm asking them, first of all, as soon as they come to see me, we do a full blood count, but I want to know where they are at, so that in a couple of months' time we can test again to see where the levels have changed in regards to what we've actually asked them to do. All right. So if you're new to all of this, or if you're a coach and you're just sort of trying to work your way around this, basically I get athletes to a minimum of taking or getting iron levels checked for every 4 months as a minimum. Now, if you are an elite athlete, there's a chance that you're having your bloods taken even weekly, so that will be checked quite often. All right. Now, once you know what their base level is for their iron, for their serum iron and their ferritin, then you can then work out, okay, we know that they're exercising this amount, we know what they're eating, and we know what supplements that they're taking. All right. So you've got to start to learn what your flow is. There's all these components that you've got to put together. All right. Now, oh, there we go. Now, iron deficiency anemia does affect approximately 500 million people worldwide. So this is not just a flash in the pan. This is something that is worldwide. It does tend to be in the third world countries. However, here in the UK, you'll notice that the stats for the NICE guidelines is that 14% of non-pregnant women have anemia. Now, unfortunately, the NICE guidelines don't actually, or they don't collect the data for non-pregnant women who have iron deficiency. Although, but they, for some reason, know that 2.5 or 2 to 5% of men are iron deficient. Just one of those lovely quirks from the NICE guidelines there. So you'll notice now that actually 14% of non-pregnant women have, or are at stage where they actually got low levels of iron. So, we're not talking about 1 or 2% here. That's a high percentage of the population. All right. Okay. So one of the main things that we really need to think about with regards to iron, in regards to iron deficiency, I will repeat this a bit later on, but what the telltale sign of when iron deficiency is starting is actually when ferritin levels dip, but iron levels actually stay the same. All right. So if you don't remember anything from today, I would like you to remember that particular sentence. All right, so now sources of iron are available both in the animal and the plant-based foods. As you can see on the left-hand side, you've got the foods, red meats, offal. They have the most amount of iron in them, poultry, all the animal sources, okay? Now that's found in the hemoglobin, which obviously you will be eating, or particularly if you've got rare meats and that sort of stuff. And the bioavailable ranges from 15 to 35%. So actually it's quite hard. So if you don't eat an awful lot of iron from animal sources, you're not going to be actually taking in an awful lot of iron in the first place. Now, if we have somebody or an athlete who is mainly plant-based, they're going to need a lot more support because bioavailability is between 5 and 12%. So that's even lower than the animal sources, okay? So we can support these wonderful guys, we can support anybody, but we just need to know where they're getting their iron level or their iron from so that we can then put in the appropriate things for them, all right? Now, there are some diseases or different pathologies that can disrupt iron absorption. So even if you don't know anything else about the client, if you've taken a case study from the client, then have a look at, have they had any of these, or do they have any of these diseases? And I'm not going to go through every single one of them, but basically celiac disease, for instance. Now that's the easiest one to really talk about, purely and simply because the villi, which is, those sort of like the piles in the carpet, I've sort of attained villi in the gut to be a bit like that, really. And effectively, if you have celiac disease, then you have no villi or very limited amount of villi, and effectively that you've got this sort of very smooth gut lining. So it's the villi that actually help the absorption of all the vitamins and minerals and everything that we actually absorb. All right, so Crohn's disease is also something that is going to have an issue. Autoimmune presentations, particularly with regards to inflammation, it's going to have an effect on the villi. So another key thing I want you to take home from today is actually brush borders, because the brush borders in the gut or in the digestive tract is one of the key mechanisms for iron uptake. All right, so just think of those little villi that you've got in your guts. If you've got any disturbances or any gut disturbances, then the villi are not going to be able to carry out their job as best as we would like them to be. That's going to affect iron absorption. So, anybody that's got any diseases of gut or inflammation, or they're taking certain medications that can interrupt with iron absorption, then all of this needs to be taken into consideration. Okay. So now, iron absorption is actually quite hard. I'm actually quite astounded when some people give me what they actually eat, and I think, where are the micronutrients in this? And you'll notice that there's a few research papers at the bottom that there are so many disruptors of iron. It's amazing that we actually have any, almost really. So polyphenols can have a disruption. Oxalates can have a disruption. So if you eat your, I don't know, if you have your piece of steak with some asparagus, with spinach, for instance, and it's raw spinach, that's got oxalates in it. It's not going to block all of it, but it could have an effect, for instance. Proteins, other divalent minerals, so calcium, zinc, and manganese, can almost sort of affect the absorption. So sometimes they compete with the iron itself. Now, on the right-hand side of this particular slide, the gastrointestinal blood loss. So in other words, if somebody has an internal bleed, it can be very small. Again, that's almost like that is a blood loss. So iron is obviously within the blood, so that's going to have an effect. Acute or chronic inflammation we'll come on to in a moment. Hemolysis, I can never say that word. I hope you don't mind me saying it that way. It's probably the wrong way of saying it. But basically, it's the process of red blood cell destruction. So in other words, if somebody has that particular disease, you have premature red cell destruction. So therefore, then obviously we've got issues with iron. And also relative energy deficiency, that's also going to have an effect. We know that very well, it's very well researched now that, somebody that suffers from REDS, they have poor bone health, they have irregular periods, can be low testosterone in males, but if they're not eating enough, potentially not eating the right foods, and therefore iron may also be an issue for these guys. Now, nutrient deficiencies, one of them in particular is vitamin C, and I would have thought most of you would know that if you're eating or having something that's got iron, you really do need vitamin C. But I also find that a lot of people don't know why you need vitamin C. Well, I'm going to hold you to that for another minute or so before we get to the next slide as to when it is. But if you've got somebody that's got REDS or basically isn't eating as well as they should be, then not only is it iron you need to look out for, you do need to pay attention to vitamin C. It's really, really important. And the reasons why, I will tell you in a moment. Now, this is where I'm going to stretch your brains a little bit. So on this particular slide, dietary iron is normally in a particular form that the body has to convert. All right, so when you eat iron from whatever sources it might be, it is in what's known as a food source. It's known as a ferric iron +3. All right, and it has to be converted into ferrous iron 2. So in other words, it's having something taken away, as a metabolite taken away. All right, now in that particular process, if the iron isn't reduced from a 3 form into a 2 form, then basically you can't actually absorb the iron. It will just stay in the blood all the time. All right, now this reduction from ferrous iron 3 into 2 is carried out by the duodenal cytochrome B. You don't need to worry about that, but think about duodenal, so in other words the gut itself. So we've got to think about good gut health in the first place. All right, now once iron is actually in an Fe2 form, this can be transported across the brush borders. Again, there we go. That's the iron, the villi. Brush borders sit at the bottom there. And basically, they're transported across the brush border membrane by an iron transporter called DMT1. All right. Now, Once it's been transported, the iron then enters the enterocytes, where it's held until signals from the bloodstream encourage the transport of iron from inside those enterocytes into the bloodstream via the transporter protein that's called ferroportin. So it's quite interesting that we've got to convert iron, first of all. It's got to be transported across the brush borders. It's then basically waiting almost for a signal. It's waiting for the next bus to come along to pick it up and encourage the transport of that iron into the bloodstream. So it's actually got an awful lot to do before we can actually get it into the serum. When we're actually, when you do your blood test, you can see the amount of iron that's in the serum. All right. So just think about when you're actually eating your iron, are you providing the right environment? Now, I did say to you a moment ago in regards to vitamin C. Vitamin C we know is a cofactor for iron absorption, but actually it's the parts where Fe2, so it's been reduced into an Fe2, it's the vitamin C that will actually almost chaperone it across the brush border. So without the vitamin C, that ability to get across the brush border and then obviously into the hepatocytes isn't anywhere near as efficient as we would like it to be. So that's the real reason why you need vitamin C when you have your iron. So it's quite interesting. I find it interesting. Some people will find it too complicated. That's fine. But what you do need to just realize is there is this biochemical process that has to happen in order for us to actually glean the iron that we're actually eating. So if you've got issues with any part of your gut, whether it be celiac disease, whether it be inflammation, whether it be whatever it is, can you now not see how that can impact the iron and the ability for it to basically be reduced, transported? It's got to have some vitamin C in order for it to be waiting for that signal in order for it to be, utilized effectively. All right. So when you're thinking about iron now, start to think about, am I putting all the right things in place? Are we reducing, gut, or are we optimizing gut health? And are we reducing inflammation? And are we putting in vitamin C? So that's one of the reasons why it's really, really thing. Now, before we move on, we've got to what we call the ferroportin. So ferroportin is regulated by the hormone hepcidin. All right. So hepcidin, so this hormone hepcidin blocks the release of intracellular iron by down-regulating the ferroportin. So in other words, that is its signal for it to say, yes, I need some, or no, I don't need some iron at the moment. All right. Now, if hepcidin isn't able to control or doesn't control that signal very well, then that's when we can get all sorts of problems. We either get really low levels or we get really high levels, and we'll come on to that in a moment. So now, the impact of low levels of iron, you can see on the slide there. All right. Now, a lot of you will be working with athletes, or you may be an athlete yourself, and you may have, had fatigue or exhaustion, or you may have, potential higher heart rate or shortness of breath, more than you perhaps might have done. My experience in clinic, I've been very lucky to run a clinic now for about 10 years. And I have also been very lucky to supervise many students in year 2 clinic before they're due to actually go out and help the world. And I've come to realize that all of the signs and symptoms can be very what I call atypical. They're very typical of that particular whatever it might be. And if you've got a person or a client who doesn't have all of those symptoms or only has one of them, maybe just dizziness, for instance, it might just think that they might not eating enough protein or whatever it might be, please make sure you check their iron levels, because clients present with different sort of, I guess, anomalies that sometimes don't fit the normal, normal sort of ideas of what they should be. All right. So with iron, if you think it is, even though that they've got symptoms that aren't really indicative of iron, I would just test it purely and simply because it's so easy to do. All right. And then you won't miss it, because if you do miss it, then basically it's one of the most easiest things that we can actually deal with. Okay. Now we're going to come on to the bit that I enjoy iron, I enjoy minerals, I enjoy all sorts of different things, particularly with regards to the human body. But the most exciting part for me is the fact that it's all about genes as well, because I immerse myself in genetics most days, and I promise you I have lost, I honestly don't know how many hours by going down what I call these genetic rabbit holes. And I actually have to put on my computer my clock that tells me what time it is at the hourly, because I can literally just lose a whole hour. All right, so let's hope that you enjoy the next bit. So on this particular area, we've got two particular genes that we're going to describe today. So the first one is the, I'm not going to say the whole thing, because in genetics we like to make things really, wordy. So it's the TMPRSS6 gene, and we also don't like to have things that trip off the tongue as well. So the TMPRSS6 gene, basically we know now that this is a key hepcidin regulator. All right. So in other words, we know that hepcidin regulates your body's use of iron. Hepcidin controls how much iron is available, because it's that one, it's waiting for the signal, it's waiting for the bus to come along. All right. And it's waiting for the signals that says, right, I need some more iron. Hepcidin says, okay, we're going to absorb some more iron from the diet. So again, if you're not eating enough iron, hepcidin can't do its job. All right. Now, the TMPRSS6 gene is involved in the regulation of hepcidin. All right. So if blood levels of iron are reduced, hepcidin production is reduced, and the body will utilize the uptake of iron, because hepcidin won't get involved. It will say, yep, signal, that's fine, more iron can come through. If iron levels from food are not optimal, this can then, or this is one of the major mechanisms of having lower blood levels. So by knowing that you might have SNPs on your TMPRSS6, you might actually be somebody that just has low iron levels naturally, and therefore you've got to really think about the iron that you're actually eating, and the vitamin C, and something else that we're going to talk about in a bit as well. All right, so this hepcidin, this protein, is there to maintain the delicate balance between the iron and the nutrition. And of course, don't forget, we can get to a stage where we have toxicity levels of iron. So if you see that somebody's got low levels of iron, whether it be ferritin or serum iron or just ferritin itself, please don't just think, oh, I'll just shove a whole load of iron in. All right, you're almost fueling a fire that's going on or internally. Okay, so because all you're doing is, the body won't be able to utilize it. High levels of iron, that becomes toxic. Toxic iron means it becomes quite oxidative. Oxidative iron becomes very inflammatory. It can then produce what we call ROS, which is reactive oxygen species. That can go on and actually damage cells. All right, and can promote cell death as well. All right. In that production of reactive oxygen species, we're also producing free radicals, and therefore we've got all sorts of problems going on. So please don't just think, oh, low iron, I'll shove that in, okay? I would always look at the genetics behind it, because it might just mean that that person is going to have low iron levels anyway, and there is another way that we need to have a look at. Now, the TF gene, or transferrin, this is involved in the transport of iron for use for storage. So we've got that ferritin, that's the one that we will actually measure. And as I said earlier on, we tend to find that if somebody's going into an iron insufficiency stroke deficiency, ferritin levels actually drop, because basically we're taking the stored iron out of the store cupboard and trying to, you know, promote it into where it needs to go, into the blood, for it to be used. Okay, so if we've got SNPs on this TF gene, then that ability to actually get it out the stored or into the stored areas, into the store cupboard, could be basically nowhere near as efficient as we would like it to be. So basically you're at risk of lower iron levels. But again, if you just check the iron, see it's low, shove in a load of iron, you're not actually understanding why. And I'm very much a why do I need to, why is it this person has got these results? What is going on? Okay, so I am one of those practitioners. I also was one of those horrible students that used to say to the lecturers, why? So I'm sure somebody's going to get back at me one day. But anyway, now, athletes do produce quite a lot of inflammation for appropriate reasons. You are doing all sorts of exercises, you're doing all sorts of different things. That's going to promote, and normally it's an acute promotion. That's absolutely fine. We know it's when it gets to a chronic situation. Now, inflammation in general increases the interleukin-6, which is a type of cytokine. And this consistently, if it is increased consistently, that's the right way of saying it, it basically, increased levels of interleukin-6 is going to block that iron release. In other words, hepcidin is almost railroaded, and basically you are going to get into a state where you've automatically got lower levels of iron. So you can actually check interleukin-6 levels on quite expensive bloods, but we can measure very, very easily you know, what you're doing and how much inflammation you're actually producing. All right, so if hepcidin is inhibited, it's going to inhibit the iron release from those macrophages. So in other words, you're going to naturally have lower levels of iron. So again, there's this seesaw event of going on. So not only have we got this complicated way of actually getting the iron in the first place, you're going to be naturally producing inflammation, which is then going to be increasing the interleukin-6 cytokine anyway, which is also going to have an effect on this hepcidin, on this you know, protein. So, you know, it all sort of stacks up that actually this is one of the reasons why the subset of society that are athletes, you do tend to have lower iron levels generally. All right, so that's just a very well-known statistic. Now, what I want to say to you is as well is that not only do we tend to have lower levels, we have the capacity of which the athletic demographic have the capacity of actually what we call iron overload. So as ever, we've either got one end of an extreme or the other. All right, now again, genetics plays a role in this one. Now, the HFE gene that codes for the HFE protein, basically, I'm going to have a little slurp, sorry. Effectively, what happens is if you're coding for the HFE protein, Fe2 plus, all right, as we've come across before. So we've got it from Fe3 so we've reduced it into Fe2, all right. What can actually happen is you can actually effectively promote this, I guess really it's an upregulation of the HFEG. All right. So what I'm trying to say to you here is majority, now it says Europeans, but it also results in regards to athletes as well. Having SNPs on your HFE gene, approximately 5 to 14% of Europeans have SNPs. All right. And basically what this happens is it will actually stimulate the hepcidin production. So in other words, if you've got SNPs on this particular gene, what it does, it actually promotes or stimulates hepcidin production. So what it's going to do is actually going to promote the absorption of iron from dietary sources. Now, sometimes you've got lower iron, but you don't know that you've got SNPs on the HFE gene. And these people, you put in iron, normally iron supplements, without realizing. And then effectively you get to a stage where you've got really high levels of iron. And really high levels of iron are oxidative. And you can actually lead to hemochromatosis. All right. So we just have to be very, very careful with this, purely and simply because this is why I'm perhaps saying it perhaps more than once, is if somebody's got iron dysregulation, whether it be low iron, you must check what else is going on, because what you can do is promote either excess iron through iron overload. And people that have got SNPs on the HFE gene, I would never give iron. Not in any sort of, decent quantities, that's for sure. All right, so just be mindful of that, okay? Because you're setting them up for oxidation and inflammation. Now, you'll see I'm slowly changing the track in regards to the impact of unabsorbed iron on the gut microbiome. So we know that the gut is the area where we absorb the iron. If you have excess iron or iron that is unabsorbed, it can actually have quite an effect on the gut itself, because basically it can cause changes, in the protective microbiome. So you'll see on the side there, I don't want to just read the slide, the words out to you. There's plenty of information on there. So just be mindful that unabsorbed iron can and will affect the gut microbiome. And this is where I'm starting to lead up to where we can actually help somebody who's got low levels of iron without having to put loads of iron in. All right. So here we go. How do we increase iron levels? We've got SNPs on TMPRS or TF. We don't want to, we may have SNPs or no SNPs on HFE gene. What do we do? Do we rely on supplementation? Do we do iron infusions? Never, in my opinion. So you're always at this sort of, decision tree as to where you go. Personally, I would always put in loads of vitamin C. I would always look at iron levels going in. I'd look at the genetics behind them, but I'd also look at something else as well. And it's really interesting because you'll see on the screen that I'm now also going to start to talk about a particular bacterial strain, and I cannot enhance enough to you. It is this particular strain. So Lactobacillus plantarum 299V. Has to have those three things, all those ducks in a row there. That's the right strain in order to increase iron levels, but because it has been found that it actually helps with the iron uptake in the brush border, and helps with the actual enzymes that are used within that particular uptake of iron. So if you've got your genetics under, and you know that, perhaps you've got SNPs on HFE, so you don't want to give in loads of iron. You've got iron levels that are really low, which you can have very easily. You know that they're eating loads of vitamin C. The next thing you can now do is actually go to one of the best ones is Lactobacillus plantarum 299V. Okay, so I can see what the time is, so I know Ian's probably going, hang on a minute, I'll just be 2 minutes. So in regards to this particular strain, there are some randomized controlled human clinical trials on this particular bacteria, and it's been done a couple of times. It's been done twice now, so we know it's not just by fluke. And the increase of iron alongside vitamin C and this particular bacterial strain has increased the uptake by more than many percent in regards, or 49% increase in iron absorption from a fruit drink enriched with this probiotic. So something that's really easy, really safe that you can actually do with your clients that's going to help to increase. So if you know what their genetics are, you know what they're eating, you know what they're doing, there's something else that you can actually incorporate into your regime as well. Now, I do have a case study. What I will do is you'll get the slides, but basically what I'm saying to you here is I had an athlete, they're doing all sorts of wonderful exercising. They're suffering some digestive discomforts. We found out that they've got SNPs on their HFE gene. We've got blood tests to reveal that the serum iron is 14.12 and ferritin was 9. And then when we look at the next slide, I put the ranges in there for you. What we did was, first of all, we increased the vitamin C rich foods. And they started to eat some red meat because they were predominantly plant-based. 3 months later, serum levels went up, ferritin levels were still quite low. We then put in the Lactobacillus plantarum 299V, and lo and behold, levels are back to where they should be. So what I pretty much say to you guys is, here's your checklist. This is, in my opinion, and of course only my opinion, but this is where I go with my particular athletes. Just check all sorts of different things. It's on the slide there for you. But also, by doing the same thing, you're going to get the same results. So perhaps it's time for a change. Perhaps it's time to find out the genetics behind their iron, and also have a look at that particular bacterial strain. So thank you very much, guys. You've been amazing. I can see that there's lots in the chats. So hopefully they're all good things, but there you go.
Wonderful. Thank you, Karen. You demonstrated your expertise in that area, as you normally do. Okay, so what's the first one? Yeah. Okay, so Scott was asking, is the probiotic available commercially? Is there a particular brand? So you can, yeah, we don't talk about brands during presentations, but I'm happy in the Q&A. So go for it, Karen.
So there is a particular brand that I use. If you want more details, just so that this can go out, that's not a problem. If you want more details on it, you're very welcome to email me. The details are on the last page of the slide. I do use a particular brand, purely and simply because I know that those trials use that particular probiotic strain. So just email me and I'll send all that info to you.
Or I'm happy you could put it in the chat box if you like.
Okay, well,
because the recording will be shared on YouTube, so that's fair dose. And anyone who's watching it afterwards on YouTube, yeah, you just need to ask Karen directly through Team Jean, and she'll tell you that detail. Okay, Gareth, are there any natural ways of increasing intake of LP229V, or is this a supplement probiotic?
So there will be, so if you eat things such as sauerkraut or those sort of things, kimchi, whatever, there will be some 299V in there, but of course we never know the amounts that are in there. It's a lovely collection of all different lactobacillus and bifido and all sorts of different things. It's never a therapeutic dose. So the actual research is on a particular therapeutic dose. So you can increase your levels, but I don't know how long it's going to take in order for it to, to get where it needs to go, because we never know how much is in any of these fermented foods.
Yeah, that's the challenge with research, isn't it? It needs specific amounts to get predictable outcomes. So I think we're in the very old stages of using fermented foods, but in the very early stages in terms of any particular research. So yeah, I mean, I'm personally in favor of fermented food in certain contexts, but for specific working more clinically, then that's where the supplements definitely come in. Okay, so Carell's asking questions in relation to the case study. Is that plant-based athlete? Oh, sorry, I'm trying to get your wording right, Carell. That plant-based athlete was not ready to switch back to meat, would support supplements, another alternative source of iron. Do you think results would be similar? Okay, if the plant-based athlete was not ready to switch back to meat. Okay, do you get the essence of that?
I get the essence of that. It will take longer. That's what will be, because obviously we absorb less of the plant-based iron, and so you can get there. It just will take longer to do so, and that's absolutely fine. No problem whatsoever.
What about the case of, an athlete really pushing the boundaries, Karen, and they're already on the edge? Any comments there?
Yeah, well, if they're really on the edge, then sometimes there's no way around it.
Yeah, you need to load the supplements and pull them back from the edge.
Yeah, absolutely.
Grell says, what's the recommended dosage for the L-plantarum 299V? Was it on the slide? Was the detail on that slide?
No, I purposely didn't. Bear with me for a sec. I've got the numbers here. The actual therapeutic dose is actually 10 billion.
Okay, so fairly moderate.
Yes.
But it's quite high, I guess, for a single.
It is high for a single, but then what we're trying to do is a therapeutic dose, so that we're putting that in. It does what it needs to do. We know it's transient, but it will not colonize, but it will do what it needs to do quicker rather than later.
Okay. And Scott's asking a really nice specific athlete question. Any considerations for sea level based athletes going to altitude to train, which, yeah, obviously the whole point is to try and stimulate hemoglobin production.
Yes. Well, those are the people that maybe you might need to, have some iron supplementation. You have to be very careful with it, but there's always an exception to the rule, and that may be the exception to the rule. I'm not against it in any way, shape or form, but I want to just be mindful that somebody that's not doing that type of going into altitude or whatever it is, then they don't need the iron, but they may do. So I'm not against that.
Yeah, the altitude, certainly any stress on the body is just amplified.
Yes.
And then if you're specifically going there to train in a training camp sort of scenario to then come back and compete, yeah, the pressures are quite high. So
yes.
Yeah,
but again, that's all about getting it in the right form. We can get iron in the wrong form that's only going to cause other problems. So just make sure you get the right form, and then yes, you can do that.
Can we come back to that form question in a minute? Because I think
No, I
that'd be
don't have a
interesting.
hornet's nest on that one yet. Go on.
So Catherine asked, is there a recommendation around meal timings and a probiotic? I've
No.
been reading about nano iron recently. What do you think about this form to get levels up? So 2 questions.
The research basically says to take the probiotic with a fruit drink, but you don't need to take that with a meal. So you can take that at any time during the day. And I always say now, the best time for somebody to take a probiotic with the appropriate, so like vitamin C, the cofactor, is when that client remembers. So if it is in the morning with their breakfast and they remember to take it with their vitamin C, then that's the right time for them. If they remember at 3 o'clock in the afternoon because they're in the car and they're doing a long journey, and so there is no wrong time to take this. What was the other question?
That was good practical advice, by the way, because yeah, we get too caught up with this one must be with breakfast and that's for dinner, and make sure this is on an empty stomach, and they're the ones we forget. I've also been reading about nano iron recently. What do you think about this form to get levels up? Yes, nano iron is okay, and that will be a form with regards to the altitudes question. We might be able to put that back to that one. The only thing is with nano iron is there's not huge amounts of info out there, so just be mindful of that you could be perhaps overdoing it a little bit because the research isn't there to see how it actually behaves. But you can certainly experiment on yourself. That's the point of it, isn't it? So let's continue Catherine's questions there to a few other types of iron. Maybe we could start with the cheap iron that the doctors tend to use in mega doses, and then go on to talk about more favorable, like gentle iron is a good term that we tend to see. Do you know what? I pretty much, there are so many different forms of iron that you can take. I say to athletes, effectively, a lot of them, it's down to what they can afford sometimes as well, unfortunately. So I tend to, I can't say the word, I can't say the retail name, can I? I tend to, it starts with an S, it's got tone at the end of it, and it's an apple flavour. And it tends to go quite nicely, and you can drink it whenever you want to, and it doesn't cause too much of digestive upset. So that's the one I say to them, you can get that readily available, so go for that one. What form though? Iron what? Can't remember. Right. Yeah. So I mean, iron, generally iron sulfate, isn't it? That gets used in this at higher doses, but then you can have constipation issues and oxidative stress and so on. Yes, absolutely. If somebody's not too worried about money, what would you suggest? Well, if somebody's not really worried about money, in regards to, I would go down the probiotic route, liposomal C, which of course obviously can be got all different places now these days, and just make sure that they're getting in majority or all of the other micronutrients, because what I didn't delve into in this particular presentation, because as you can tell there was lots of info and we could have gone on all sorts of different trajectories, that iron and vitamin C, you also need zinc and magnesium as well. So just be mindful, you know, you've got to make sure you've got these micronutrients going in. And if you know that your client has got a bit of a, you know, dodgy gut microbiome, or they've got, you know, digestive issues, then you might want to up the level slightly, not the iron obviously, but the vitamin C and all the other stuff, because of the absorption that they may or may not be doing. So would you be, if somebody's got iron concerns and maybe they're slightly under iron blood levels,
Yeah.
is it fair to say you would start firstly with the specific probiotic and a multi-mineral?
Yeah.
But then obviously higher deficiency levels, you'll add in the specific iron.
Yes.
Okay.
Now, interestingly, this particular probiotic strain, the one that I quite like using, has a very minimal amount of iron and vitamin C with it. It's like really low quantities. It's never going to, send you over high, whatever. But it's enough, basically, to really sort of get those iron levels back up to where you really need to. Yeah.
Yeah, I'm asking all the questions now. Any last questions, everyone, before we finish? Because I'm about to dry up with questions. So I was going to ask another one that with the specific probiotic you've been discussing, is there any contraindications to keep taking it month after month? Or in terms of microbiome health? Or should you maybe dose it for a few months, check your iron levels, and then maybe go into a more multi-strain? What's your thoughts on that?
My thoughts are, so the initial immediate thing is obviously the iron levels. So I would take it. I tend to say to somebody, take it for 2 months. It's 1 a day. If you don't like eating or taking capsules, you can pull them apart and actually just dissolve it. It goes into a paste on your tongue, no problem at all. I would then test after those 2 months, because I wouldn't change anything else. I like to know what else is, don't do multiple things and you can't work out what has worked and what hasn't worked. So I do this for 2 months, get them to do another blood count. If it has gone up, but it hasn't gone up as much as we would like it to be, then we would then address all of the other minerals that are going in, and we would do another month. So it could potentially be 3 months. If after 2 months it's gone up to where you want it to be, what I would then do is I would take one, and this is a bit where people start to forget, I would take one every sort of 3rd or 4th day. So I'd then it would be tapered down. So you'd be taking 3 boxes, but the 3rd box you would take every sort of 3 or 4 days, just to keep that going until we know that those levels are back to where they should be. And then basically after that, you should be absolutely fine.
Good advice. Right, Togo. Okay, so it's interesting on when to take probiotics. Find mornings are better because if I take with evening meals, then they're super thirsty, during the night. If you take a probiotic with vitamin C in already, then you're saying you can have it on an empty stomach, ?
Yes.
Still find the biggest benefit is high levels of fermented foods work really well compared to a probiotic.
Yeah, absolutely. I've not against probiotic foods in any way, shape or form. But I do find, particularly in the athletic community, when you are trying to get somebody's iron levels up because of whatever reason it is, I will go to the probiotic first in order to get them, and then we will then up their foods, fermented foods afterwards, and we will then keep those going as well.
Yeah, so go more specific first and then taper off into more of a generalized approach.
Yeah, absolutely.
Cool. It's good, sensible advice, folks. So thank you, Karen.
No
really,
worries.
really appreciate it. And thanks to everyone who's joined us for the hour. And we've got another one next month. We've got an American lady who works in professional basketball. So I'll be interviewing her. So that should be good as well. So thanks again. And you'll get the slides and so on tomorrow.